All right, so in today's lesson, we're going to talk a little bit about reflections. We want to be able to perform a reflection and also tell what kind of reflection has been done. Okay, so let's go ahead and fill in the blank with the word reflection. A reflection is a type of transformation that acts similar to a mirror, with an image reflected over the line. The mirror line is called a line of reflection. Also, you might see line of symmetry show up. So we'll also include that in our vocabulary. Line of symmetry. The original point is called the pre-image, and the reflected point is called the image. Okay? Oftentimes, I will use the word prime. So this is point A, but this would be point A prime. Okay? Again, we read it as A prime. Prime means like the latest edition. Okay? So if we're going to choose iPhones or something like that, we're going to get the iPhone Prime because it's like the most updated. Okay? So point A would be considered the pre-image, and then something happens to it like a reflection, let's say it's reflected over, and it turns into something like A prime, and A prime is going to be called the image. Okay? So that's a little bit of basic vocabulary before I just start talking. Okay? So a reflection in line M, this is line M, this blue dotted line, is a transformation that maps point P in a plane to point P prime. P, sorry, it's a P, this should not say P prime, this should say P is the point that has been reflected. All right, so this P is my pre-image. And P prime is the image. I wish we called it like image and then post-image, but we don't. We call it pre-image and then image. Okay. Did I say that wrong? P prime is the image. Pre-image, image. Yep. No, that's right. All right, so what do you notice about the ordered pairs P and P prime? Well, when you look at P, it's mapped at coordinate 1, 4, and P prime is mapped at coordinate 4, 1. What do you notice about the pairs of coordinates? The x and y values. What do you see? The x and y values have been switched, right? So we're going to write that, the x and y values switch. That's not for all reflections, but just on this one. So let's talk about the equation of that blue dashed line. Well, what is the intercept of that blue dashed line? In other words, where does it hit the y-axis? Don't be shy. Where does it hit? At the origin, right? At what equals 0? At y equals 0. So this b is equal to 0. All right, so now let's try to figure out what the slope is. What is the slope of this line? Coordinate 1, 1, coordinate 2, 2, coordinate 3, 3. So each time we're going up and then over the same amount, right? So I could go up 3, to the right 3, or up 4 to the right 4. Okay, so what do you guys think the slope is? The slope is up some number over the same number. So yeah, somebody said the slope's 1, and that's exactly right. The slope is 1. So the slope is 1. So what's the equation going to be for this line? Y equals 1x plus 0. But that's an awful rude thing to do as an algebra graduate, right? You wouldn't write a couple of those things. First off, we don't typically write plus zeros, okay? Because really, we would never end. We would just continue to add plus zeros, right? And then this 1 times x, I know that it's 1x if you don't even write the 1, okay? So y equals x is going to be the equation of that dashed line. So if the equation of the line of symmetry is y equals x, then that's all you do is switch the x and y values, okay? If y is equal to x, then it should be evident that that's all you have to do, switch them, okay? Because they're the same thing. But now let's look at some other reflections that are not over the line y equals x. Well, let's take a look at this dashed line. What is the equation of this dashed line? Does it have a slope? It has a slope, but the slope is 0 because it doesn't rise any at all. What about the intercept? Where does it hit the y-axis? At 4. So y equals 0x plus 4. Again, we don't typically write if it's 0x, it'd be y equals 0 plus 4. Again, we don't have to add a 0. So y equals 4 is this equation. All right, maybe that's too much work for you being an algebra graduate, but this is still early in the semester. So kind of walk through some of these ideas that you have already. So anyway, so let's look at point V. Point V is at 2, 6, but point V prime is at 2, 2. Okay, so let's take a look at what happened. Well, we see that this was 2 points above that dashed line, so we just need to go 2 points below it. All right, so that's a reflection. On the next problem, it doesn't actually give us the line of symmetry, but, well, it does say that it's been reflected across the y-axis. But could we have figured that out? Maybe. Let's see what we could do. Could we start at M and count over to M prime? How long is that yellow piece of graph there? From -6 all the way up to 6. So it's 12, right? So if it's 12 units long and we just decided, all right, well, let's count over to the right 6. 1, 2, 3, 4, 5, 6. At that value, that would be our line of symmetry. What's the equation of the y-axis? It's a vertical line. So actually it doesn't have a slope. All right? It's a vertical line. So to write it like this, y equals mx plus b, actually doesn't make sense to do. Okay? So the y-axis, its equation is actually x equals 0. All right? So I could have very easily said m has been reflected over the line x equals 0. Okay, so let's take a look at the point M. Point M is at -6, 7. And point M prime is at 6, 7. Basically, we just count 6 away from the line of symmetry and then another 6. Okay, so we're going to go a little bit faster here. So if we're at 1 comma 10, and our line of symmetry is at y equals 6, then that means that I would have to go down 4. So I just need to go down 4 more. Going down 4 more from 6, 6 minus 4 would give me 2. So 1 comma 2. If you're given a line segment, just do each point. So let's take 2, 8, and let's take 2, 4. And we're going to reflect it across the vertical line, x equals 3. So from 2 to 3, I've went over 1 unit, so I just need to go over 1 more. So when we go over 1 more, we get the image of a line segment that connects 4, 8, and 4, 4. Connect it. So this machine's going to mess with me a little bit, but this is supposed to be a line segment. So you have your end point on top and bottom, and then you try to do that line segment there. All right, let's let you practice on the next one. Give that one a go. All right, so if you're working in class, hopefully that was enough time. If you're working by video, hopefully you did pause the video and go ahead and try that one on your own. Okay, and hopefully your picture actually looks better than mine. I'm having a little bit of issues with the technology on my side. All right, so what if we have to do a triangle? Well, if we have to do a triangle, we're going to do it just like we did the line segment, except for we're going to have to do 3 points instead of just 2. Okay, so we're going to take our pre-image points. I'll start off with the -8, 0, the -9, 3, and the point at -7, 3. And I know that my line of symmetry is at x equals -4. And then we're just going to translate this thing over. I said translate, reflect this thing over. So from -8 to 4, looks like I counted 4. So I need to go 4 more over. From -9 to 4 is 5. So I need to count 5 over. And from -7 to 4 is 3. So I need to count 3 over. 1, 2, 3. All right, and then you plot those points. Typically, though, what you're going to have is now this looks like it could have been a translation, doesn't it? Doesn't it look like I could have just taken that and slid it over? Okay, so in some problems, what you're going to do is you'll have sometimes what you'll be given is a point, and this will be called A, and then this one will be called A prime. If this point right here is A and this one is A prime, could that have been a translation, or does that one have to be a reflection? That one has to be a reflection, right? So, and then what you'll do is you'll just write down the points of your image. So it looks like our points are 0, 0, the origin. It looks like the one that was at -9 came all the way over to 1, 3. And then the one at -7 came over to